5th of October 2020. This is our Supplier Management lecture in, I see a mistake here, MBW7. Today we're going to depart for a while from Python, and we're going to come back to Python later on when we see blockchain in detail. But first, I feel I need to give you an overview of industry 4.0 systems, production systems, and their link to a digitalization. Okay, so first of all, it is interesting to know that such Industry 4.0 systems can be understood as socio-technical complex networks. Okay, we'll see in a minute what this means. Some of you have visited my classes before, so you will, something will be familiar. These networks are formed by cyber physical nodes and edges. Here, the important word is cyber physical. This means basically that they are formed by machines, by humans, by elements in or sensors in machines, or drones, or all sorts of sensorized nodes that communicate in a way that value can be created throughout the network. Communicate in a way that value can be created throughout the network. So throughout these networks, or these nodes, as I said, they can be these nodes and edges. Can be described in a graph, which is a group of nodes and edges, and these nodes and edges are cyber physical elements. That's why we talk about cyber physical complex networks. Okay. So far, any question? In a way, we can describe this, and as I said, this might be familiar to some of you from past lectures and other semesters. In a two-dimensional grid, where Here we have the social element. Here we have the technical element. Okay, and here we have the individual person. Here we have the relationship level. Here we have the managerial level. And here we have the organizational level. At the personal level, you want trust, worthiness. At a relationship level, you want trust. At a managerial level, you want empowerment. At an organizational level, you want alignment to meet the strategic goals. As I said, we have seen this already. On a technical level, you can find the machine, let's say, lower level, machine or shop floor. You can find many machines put together. Imagine a production line, a factory. You can have a factory with many production lines put together, and you can have a supply chain with many factories that need to be coordinated. And this is what we're talking about here: supply chain management. Okay. So we want to get to this level, to this upper level, at an organizational level, which means that we need to control all the previous levels before. Use another color so that it's more understandable. And we need to develop different strategies that cope with this challenge. You need to be taking care of defining or describing how the individual behaves on the shop floor, how the individual behaves on the line, how the individual behaves in the factory, and how the individual behaves on the supply chain level, and how the relationships are in the shop floor, in the line, in the factory, in the supply chain level, how the empowerment is on the shop floor, in the line, on the factory, supply chain, and how at an organizational level you create a cascading of goals from supply chain to the shop floor and back up, top down, bottom up. And this is what it's all about. And the thing is that when you have such a challenge in which also complexity is constantly increasing, because of mass customization, okay, you need to, in order to cope with this challenge, you need to do something, okay, because otherwise it's impossible to deal with. And for this reason, we need, or people have come to the digitalization. Okay. The fact of the matter is that these networks that we talked about are moving in this grid, okay, are being created and destroyed constantly in this grid. And now we look for a third axis getting out of the paper, which is going to be digitalization. digitalization process, if you wish. Okay? In German, Digitalisierung. Okay. And this digitalization process or activity undergoes three very specific phases that we're going to depict today. The first one is to gather information. Okay. I. And let's put it color here. So we have I, information that is gathered and is acquired and needs to be structured. When you have the information, then you want to create some knowledge from it. Okay. And once you have created knowledge from it, then you want to make sure you use that knowledge to create value. So basically, what you have is a sort of a plane, socio-technical plane. This is the social and technical level, in which you have embedded a network, a complex cyber-physical network, and then this plane is going to be traveling throughout space in order to make from the information gathered. You gather information, you transform this information into knowledge, and then you create value from this knowledge. Okay, and that's why you get digitalization. Okay, so we're moving in a sort of a cube, and this is the way we will depict it from now on. Any questions? Questions, please. Questions? Question? Okay. Well then, within this framework, let's explain the digitalization process in detail. Okay. we have the information. Part information. The first thing we need to do is to acquire the data. Data acquisition. Because without data, nothing will happen. Okay, this is the first step. The data is acquired by putting sensors on the nodes and by creating an infrastructure of communication between the nodes. Uh, 4G or 5G now, it's whatever protocol you use to communicate. This way, well, you put the sensor on the nodes, and these sensors are RFID, or you can put EEG on the workers to measure their brain activity, or you can put wearables to measure their health. You can put many things. Okay, just to get data from your nodes. Blue. Let's use blue. First thing is data acquisition. Make sense? Any questions? Second step is data structure. And this is what we have been doing lately in our first lectures. Okay. First thing you need to do is to, when you structure your data, to create a selection. Real data have a lot of noise and a lot of not valuable information. The first thing you need to do is to select what you're looking for. What we were doing when we were looking at our machine learning models the past weeks. Once you have done a selection and you know what you're looking for, you want your data to be clean. Cleaning. Okay, so you get rid of the noise. Noise cancelling techniques. Once you have done it, you want to transform of the data to make it understandable. this cleaning, this selection, cleaning, and transformation is what we have been doing all the time since we started this lecture. When we were representing graphics of our data sets, we were transforming the information so that we could understand it. When we were cleaning our data set with TSNA or PCA, well, TSNA, it's both cleaning and transforming. Well, you can say TSNA, here PCA. It's also selection. I mean, the methods we learn, or here hierarchical clustering, clusters. The methods we learned were designed to perform first a selection, then a cleaning, and then a transformation, so that we get a data structure that can be analyzed. Questions so far, please? Okay, kind of calm. Ask. I mean, so far, I should be hearing a lot of questions. Can you hear me? Yeah, it's still kind of calm down. Out. Farbe tut gut. Okay, so once we have cleaned or selected, cleaned and transformed the data, and we have our information prepared, we continue with the knowledge creation. And here is where it gets a little bit interesting for our business, because here we perform business analytics. And here is where actually the management starts. What color do we use for knowledge? So here, this knowledge creation after preparing the information. We start with business analytics, and there are different strategies that go deeper and deeper. Okay, and the first one is to create a descriptive business analytics model. Descriptive. descriptive. In which we only represent the information that we have created by our cleaning, selection, cleaning, and transformation. So it's just a graphic representation. This is where most companies currently are in their business analytics. Just a descriptive one. Okay, this is what you find, for instance, when you go and see Power BI. From Microsoft, most of SAP is just descriptive. Okay, so this is just descriptive business analytics. It's a better dashboard, if you wish. Okay, it's a digital dashboard usually. Then you can get to the next level, which is diagnostic. Get to the next level. Which is diagnostic, in which your business analytics, your business intelligence gives you a diagnosis of what is going on. So it helps you diagnose the case. Okay, this is what, for instance, it's used in hospitals right now today with deep learning models. What can be done with some regression? Let me put some examples. So here you can use deep learning to characterize information and diagnose. You can use LSTM, long short-term memory networks. You can use some Monte Carlo stuff. We will see later on what is the problem with this. But, then the next level is LSTM. I'll put LSTM somewhere else. I'm going to put just Monte Carlo. Monte Carlo models. The next level is the predictive. So here, the most advanced technology is quantum computing. You can see one of my papers on my website about this, but you can also use long, short, and memory networks to predict. You can use quantum computing, as I said. Even linear models are okay. This is something that is, as of today, it's not really very deepened, this technology, and when used, it's used in a very shallow way. And then you can go and use prescriptive. business analytics. So the analytics technology prescribes a solution, prescriptive business analytics. It gives you a solution that was not there before. So this is actually business intelligence. Our string here. So basically, supplier management, as of today, it's basically being done on this level, business analytics level. But in most of the companies, this is done with, at most, a descriptive Power BI or a descriptive business analytics approach. The fact of the matter is that companies do not have the know-how, and people working in supply chain management don't have the skills to advance into the digitalization strategy or business analytics strategy. That's why I am so convinced that you guys need to learn Python and all related methodologies to get an advantage and be able to design diagnostic, predictive, and also prescriptive business analytic models for your companies in the future. I know some of you don't like it and feel a little bit uneasy because it's new and because it's something that you don't feel comfortable with, but it is the future, and I want you to be fit for the future. That's why I am teaching it. Okay, so if you don't like it, I am sorry. Make sure you start liking it, because you're going to be facing such systems as soon as you get in touch with your future employer. And if you don't learn it, at some point you will just be in the job market without a job. Okay, so this is the way it works. Well, we have business analytics, and we have information and data acquisition, data structure, and business analytics. Do you have any question so far? Questions? Okay. Well, business analytics or prescriptive business analytics go farther. Okay, they continue, they don't end up here. And they have two versions of it. Okay, and they go into the value creation. Value creation, which has also two steps. The first one is decision making. the second one is operations or action. Green for it, for the value. Okay, and then we have our decision making. And here in decision making, what we have is business analytics that goes beyond, as I said, and we find here a prescriptive decision support. Okay, you can find this, for instance, in some material management, spare parts systems in which your intelligence is providing you some support on what to purchase or what to replace. Okay, decision support. And you can also find here, going even deeper, prescriptive decision automation. And here is where you can really talk about business intelligence, BI. All the rest is just business analytics or business support, and it should be called by its name. I know Microsoft calls it Power BI, but it is, I mean, it could become some prescriptive decision automation software, but as of today, as of now, it's basically just used as descriptive dashboard. Anyway, any questions so far? We go from information to knowledge creation to value creation, and in order to do so, we create, or we use our framework, our digitalization framework, value, knowledge, and information. Okay. And our supply chain management activities try to move us on through this complex world or complex networks at this level. It is worthless. It is worthless. Es macht keinen Sinn. It is worthless to learn theory of supply chain management without knowing what you already know from Python, that the digital world has a substrate of data. Don't try to become or get out there at the job market and try to not confront this reality, because at some point, as I said, you will be jobless. The sooner you confront the digitalization reality, the better for you and your families in the future. So, ich wiederhole diesen letzten Satz auf Deutsch, weil es so wichtig ist. Wenn ihr versucht, euch zu bewegen in den Markt, auf dem Jobmarkt, ohne in der Digitalisierung einzusteigen, irgendwann in 10, 15 Jahren seid ihr arbeitslos. Je früher ihr euch mit diesem Kram beschäftigt, desto besser für euch und für eure zukünftige Familie. Wenn ihr hier jetzt einsteigt, dann habt ihr eine Möglichkeit, eventuell die Kurve zu kriegen, in Anführungsstrichen, und auf dem Markt zu glänzen. Ihr braucht nicht Programmierexperten werden, ihr müsst nur euer Geschäft kennen, aber aus der Sicht der Digitalisierung. Das heißt auch im Sinne von Programmiersprachen. Und Beispiele habe ich euch ein paar gegeben. Ich weiß, ihr hasst mich vielleicht eventuell und ihr flucht, aber keine Sorge, mein Ausweis ist aus Plaste, weil es so viel draufgeschissen wurde bereits. Vollkommen egal. Ich mache nicht, was ihr möchtet, ich mache und ich gebe euch, was ihr braucht. Okay, so any questions so far? Good. Then we'll make a little continue then. With our description of the digitalization process, and one of the basic challenges that we face is in the data structure. Okay. I make a little sign here. We have said or described our Industry 4.0 systems, production systems, as complex networks. Okay, we know that a complex network, a complex real network, has a probability of a node attaching to another node with degree k following a power law, being gamma the power degree, or the degree exponent, sorry, degree exponent, and being usually between 2 and 3. Fact of the matter is that our networks or our data are created through sensors that are placed on nodes. So on each node, we paint one node big, there is one, let's say, sensor that is sending data or is creating data as a function of time. each one of the nodes, it can be cars, it can be customers, it can be people, it can be drones, it can be anything. Each one of the nodes is creating constantly information for our system to analyze. Social media, okay? So the fact of the matter is that this sensor is creating data that is a function of time, but this data is embedded. This data is by definition embedded within a complex network. In other words, it's within a graph. Okay. And this is problematic because it makes it a lot more difficult to get information because the graph is depending on time, because the data is depending on time. So some examples of this is to give you a rough are, for instance, the data being gathered by automobile, suppliers or automobile OEM. You gather data about your customer behavior. So all of these cars are equipped with sensors that are sent regularly, and you have your CO2 in time, or when you have your CO2, you have your Verschleiß, you have your parts exchange, maintenance, you have your liters or gallons per kilometer, you have your GPS coordinates, where you go, and so on and so forth. So, and all this data is a tensor that is a function of time. If, as an automobile OEM manufacturer, you want to create a business analytics strategy out of this data, you have two options. You can either transform the data into a 2D, let's say, matrix, or you can perform your business analytics on the graph. The way to explain this mathematically, this is just an example, as I said, with the cars, is that the data that is used typically in finance or in image recognition, so on and so forth, has an Euclidean underlying structure, meaning that the distance between data points is constant or is defined. for instance, you have a picture. In the picture you have pixels. The pixel E and the pixel J, they're always at the same distance. Okay, in the pixel E you have your RGB color code, and in the pixel J you have your RGB color code. And you have a distance that it never changes, or it can be transformed linearly, but it is defined distance. When the data structure is on a graph depending on time, then there is not such a thing as an Euclidean structure of the data. As a result, several things happen. You remember from other classes that the graph given by a set can be defined by its Laplacian. Laplacian of the graph, L. You remember that we can find the eigenvalues u minus 1, which is delta are the eigenvalues, and this u are the eigenvectors or linearized. Okay, we can normalize this Laplacian. Which, as I said, describes the structure of the network, by saying that our Laplacian is minus 1 divided by the degree of node I, the degree of node j, for I not equal to j, 0 for I equal to j. Okay, so this is a normalization that is usually done. And this normalized Laplacian describes the structure of the network, but its eigenvalues and eigenvectors are constantly changing, because the graph is a function of time. What we want is to extract through a business analytics strategy, patterns of information within the network. And in order to do so, we take the signals of the data from each node and perform a convolution on each node. Given by, so if there is a node A, let's say, okay, that has sensors on it and it's creating data all over time, and then we have a series of nodes in its neighborhood. And these nodes are describing a group. The vicinity of the node A, let's call this group B, and the data in A is given by a vector or a matrix depending on time, and the data of the nodes of B is given by another vector, another matrix. Then we can say that the convolution applied to A equals the sum of the nodes in B. Okay, I'm going to call this group NA, so the manifold around A, of some coefficients around the node A within the group B times xB. Okay. And this is going to be equal to phi sub A0 times xB plus phi sub A1 times S times xB plus phi sub A2 times S times xB plus phi sub AK times SK times xB. This way, or by doing so, we combine the signals on the node with the graph structure given by the normalized Laplacian signals on the node xp, okay, or signals on the, not on the node, on the node vicinity. Okay. By computing set A through a gradient descent algorithm, we can compute the coefficients phi sub a b, and therefore we can apply a convolution operation, a convoluted operation directly on the graph, which supports business analytics without loss of information. This loss of information is avoided, the loss of information that would have happened if we had transformed the data into a 2D matrix, because when you transform the data, you lose information. Okay. As we already know, because we have seen it in the previous lectures. Okay, so this methodology is called geometric deep learning. Geometric because we are working on a graph. Deep learning because we have a convolution. And lean because our networks are lean management related networks. Lean cyber-physical complex networks, if you wish. You can look for this title, Geometric Deep Lean Learning. I recommend that you look for it in Google. I have a publication about it, and I think it's interesting for you eventually in the future. This is the latest knowledge about these methodologies. Okay, so far. Any questions? Well, then I will upload the video on the website as usual and send you the PDF via email in a couple of minutes. Okay. If you have further questions, do not hesitate to contact me, and I hope you have a nice rest of the week. Stay safe, stay